Hey everyone, welcome back to my number sense series. In this video, we're going to be doing the third case in our summing squares series. This is the 101 case. Now, I call it the 101 case, but in my head, I call it the weird case because it is so odd. It's like not really like the other tricks we've seen, but it's super important, and these problems are really, really hard without knowing the trick, so it is very important that you know it. So, first of all, what are the conditions to use the 101 trick? Well, the conditions are as follows. You are summing the square of two-digit numbers, for example, 13 and 29, and here's the important part, the tens digit of the first number and the units digit of the second number add up to 10, and the units digit of the first number is 1 greater than the tens digit of the second number. So 3 equals, of course, 2 plus 1. And that is the criterion for the 101 trick. And it seems very random, but if you stick around to watch the derivation, it's actually quite beautiful in my opinion. But please remember this. I know it's kind of confusing, it's kind of complicated, it seems really random, but it's so helpful. So, how does the trick work? Well, first of all, let's just find the answer to this problem. 13 squared plus 29 squared. Hopefully you have memorized your squares, so we can do the computation directly. And what we're going to get is 169 plus 841 equals 1010. And what's interesting about 1010 is that it's actually 10 times 101. And so we start to ask ourselves, is it true that whenever we do a sum of squares with these criteria satisfied, that the answer is going to be a multiple of 101? And the answer actually, surprisingly, is yes. And I'm about to actually prove that. If you know some algebra, if you know manipulation of variables, if you are comfortable with doing that, you can watch the derivation because I think it's very nice and very important to know. But if you don't know that, it's absolutely fine. So now let's actually prove this. Well, first of all, let's think about the two criteria and what they mean for the number. Our first number we'll call AB. 13 is AB if A equals 1 and B equals 3. So it's like AB squared. And what's our second number? Well, what's the first digit of the second number? The first digit of the second number is B minus 1. And the units digit is 10 minus A. So it's kind of like this number squared. And this looks kind of messy. I'll clean it up right now. Because what is the value of the number like AB? The value of the number AB is 10A plus B because of the place values, right? For example, the value of the number 13 is 1 times 10 plus 3 because 1 has a place value of 10. So our second number is going to be equal to 10 times B minus 1 plus 10 minus A squared plus squared. All right. Now, what is this? It's 10b minus 10 plus 10 minus a, which is 10b minus a. And now when we expand this out, we're going to get 100a squared plus 20ab plus b squared plus 100b squared minus 20ab plus a squared. And something beautiful happens. These cancel out, and what we get is 101a squared plus 101b squared, and we'll get 101 times a squared plus b squared, which is just amazing. I mean, wow. I don't know who discovered this, but wow. So we can see that the answer is going to be 101 plus a squared times a squared plus b squared. In other words, the answer is 101 plus the square of the first digit of the first number plus the square of the second digit of the first number. So here it's going to be 1 squared plus 3 squared equals 10. 10 times 101 is 1010. So this is our trick. So now let's move on. We have 84 plus 32 squared. Now let's just verify really quick that the trick does in fact apply. So we have, 8 plus 2 equals 10, very nice. And also 4 equals 3 plus 1, very nice. Remember, it has to be in order. It has to be this 4 is this 3 plus 1. It can't be like this is this plus 1, no. Okay, so now we can just apply the trick. Well, the trick is what's 8 squared plus 4 squared? That's going to be 64 plus 16, which is just 80. So it's 80 times 101, and of course we know that whenever we multiply a number by 101, at least a two-digit number by 101, it's just itself repeated. So it's 8080. And that's our answer. Now, our second case, first of all, let's verify that the trick applies. 4 plus 6 is 10, very nice, and 3 equals 2 plus 1. So it does in fact apply, and we can use our trick. So our answer is going to be 4 squared plus 3 squared is 25. 25 times 101, 2525. Here's that right here, just in case you didn't quite catch what I was saying. And finally, our last problem. And you know, of course, if you've been watching the channel, you know that sometimes I like to make the last problem, you know, a bit of a trick question, a little bit harder, and here it is no exception. Because, I mean, let's try to verify the trick. 5 plus 6 is 11. That doesn't work, and 3 sure isn't 7 plus 1. So, at first glance, you might think, okay, well, I can't use the trick. Okay, what else can I do? But here, you are supposed to use the 101 trick. It's just reversed. Because 53 squared plus 76 squared equals just 76 squared plus 53 squared. And when we do this reversal, we see that actually we can use the trick, because 7 plus 3 equals 10, and 6 equals 5 plus 1. The trick does actually work, we just have to swap the numbers. And of course, since our answer is based on the first number, when we swap the numbers, it changes the answer. So now we have 76 squared plus 53 squared works. And so we are, of course, going to always look at the first number, 76. So our answer is 101 times 7 squared plus 6 squared, which is 49 plus 36, which is 85. So our answer is 8585, 8,585. And that's it for that trick. So overall, this trick I would say is kind of the trickiest one, but it's only tricky because it's hard to recognize when it works. It's a little bit hard to memorize the conditions, and sometimes they will try to trick you very deviously by simply reversing the numbers. But if you can keep that in mind, if you can always recognize when you have to use the trick, the application of the trick is super simple. So hopefully you guys have memorized this. 101 times a squared plus b squared. The derivation isn't necessary, but it's very beautiful. And that's it for today. I'll see you next time.